Okay, in this video, we're going to look at what annuities are and all the different words and terms we use in this topic. As we often do, we'll just tell the story here and save calculations and examples for a separate video or two. So imagine we have a bank account earning 5% per annum interest compounded annually, and we are investing $1,000 at the end of every year. So it's not just one investment, but we're going to pump money into the account over and over again. Firstly, I'd like to say that this situation of repeated investments of money should really remind us of a loan repayment, where we are repeatedly paying off chunks of our loan, and mathematically, those things are pretty much the same. And so that's why I've deliberately recycled a lot of the code and animations and stuff from that video on loan repayments, because I do want you to see the connection between these two ideas. It might even be worth going back to the video on reducible interest loans if you're not as familiar with those. So suppose we have a timeline here where we are just going to track the first 3 years of this situation. In the first year, we have no money in our account because we haven't put anything in yet. Okay, note we're only putting in each $1,000 at the end of each year. Might seem a bit weird, but that's how these things are often tracked for us. And so if our bank account is empty, it can try to earn its 5% interest for the year, and that would normally happen by multiplying by one copy of what we have with an additional 5%. But of course, having nothing in our bank account means that there can't possibly be any interest. The account is still empty. But it's here at the end of the year that we make our first contribution, and so the amount is going to increase by 1,000. We're going to add $1,000. And so now we have exactly $1,000 in our account. So let's now jump into the second year. We earn interest, but this time on the $1,000 that's in there. And if we run the 5% increase, we get $10,050. But now we're going to pump another $1,000 in, leaving us with $2,050 at the end of year 2. All right, third year, same thing is going to happen. We earn interest on the $2,050 we have. The 5% increase brings us to about 2,153. Then we pump in our third contribution of $1,000, bringing us to 3,153. So every year, two things happen. Whatever amount we have in our account at the start of the year is going to earn interest over the course of the year. So in this case, we're going to increase by 5%. So take one copy of what we have and add an extra 5%. Then at the end of each year, so after earning the interest, we're going to pump in an extra $1,000. And that's the pattern we need to repeat, but again, it is mathematically difficult to repeat both a multiplication and an addition. So just like for reducible loans, we again have two approaches. If we know the machinery, we can use a geometric series. Otherwise, we'd use tables or a calculator. Okay, and again, especially for standard maths, the trick is recognizing that such a story where we repeatedly pump money in is actually beyond the scope of our usual mathematical powers. It's not just a simple compound interest calculation. And we need to be super aware of this so we know not to use the formulas or whatever and simply trust tables that will be given. And if you look at the picture, I hope this is clear. By the end of the timeline, the first contribution of $1,000 has earned 2 years of interest. The second has only earned 1 year of interest, and the last one hasn't had time to earn any interest. And so if this stretches out over a longer period of time, there'll be so many compound interest calculations with different time periods to add up, and that's what makes it a trickier problem than other investment situations we've seen before. Okay, so let's have a look at some of the terminology we might use here. So let's bring back the process from before. That number that we finished with at the end of the story, the $3153, that's called the future value of this annuity. Okay, that final amount we have in the account after pumping in that last contribution of $1,000. Okay, and so that's what we have at the end here. Now, this part might seem a little weird and even random at first, but I want you to imagine a sort of parallel story. One where we are not pumping in the green $1,000 every year, but where we invest one single amount. Some amount that lives in this red box here at the very beginning of the story, so before any time has passed. And we insist that in 3 years, by normal compound interest, without any extra contribution, so now we're no longer pumping in that $1,000 every year, purely by stock standard usual compound interest, we want to arrive at that same future value of $3,153. So your usual compound interest is just doing the 5% increase 3 times, which means we're multiplying by the 1 plus 5% thing to the power of 3. And so what amount has to go in the red box? Well, to work that out, we can reverse that multiplication by dividing. And if we divide that future value, that 3,153, by 1 plus 5% cubed, then we get something like $2,724, okay? Bit of a random number there, but that 2,724 is called the present value of our annuity. And you might be like, why do we care about such a strange number? The idea is this. It establishes an equivalence between repeated investments over time and a one-off investment at the start. See, it gives us this connection between two very different stories. The green story, where we are repeatedly pumping money into the account over and over again, the $1,000 every year. And the red story, where we chuck in one big amount, the 2,724, and just let it sit until it grows into the same final $3,153. Now notice that in the green story, by the end of the 3 years, we've pumped in a total of $3,000. I guess the extra 153 must be all the interest we accumulated along the way. But the present value here is slightly lower than that $3,000. And that's because the whole thing begins earning interest immediately. So for the whole 3 years, and that's why it's able to arrive at the same final value of 3,153 with a lower total investment, because it was all done at the start and all of it was earning interest for the whole time. Okay, so we have this connection between the green story and the red story, but why is that helpful? Well, actually, this connection lies at the heart of calculations behind things like loan repayments. See, if we set up an imaginary loan, say $50,000, with monthly repayments of $2,000 or something, then the $50,000 is a one-off amount. I borrow $50,000 at the very beginning, and that's all. I'm not going to be borrowing any more money after that. But over the duration of the loan, it's going to keep charging interest against me. But the monthly repayments of $2,000 are happening over and over again throughout the course of the loan. And not only does that repeatedly subtract from the loan, but I shouldn't need to pay interest on all the money that I repay, so each contribution of $2,000 is also going to compound in my favor. So that means these repeated contributions of $2,000 behave just like an annuity. Sure, I'm paying off a loan, I'm not putting money into a bank, but the maths, the calculations, don't really know or care about that. Mathematically, it's the same story. Well, how about the $50,000? Well, since it's the one-off amount at the very beginning, then it behaves exactly like a present value. It doesn't matter that the red story is a loan and the green story is a repayment. Again, the maths does not know or care. The point is, we want an equivalence between the two stories. Why? Because the green stuff we pay back, that stuff has to equal the red stuff we owe. That's the simplest way to see a loan. You pay back what you owe. And all the usual complications with interest and reducing the interest charged as you pay off the loan, all that mess can be automatically handled for us if we have easy access to this relationship between the green and red numbers, which is exactly what things like present values do for us. Now, there are other practical situations that could be handled by this connection between the green and the red stories, but we'll show you when we do some examples, because I know this might still be somewhat vague right now, and the next step to help make it more concrete is really to see it in action, to show you what sorts of problems we might be interested in solving and how to navigate the tables I've mentioned earlier. Okay, so that's what we'll do in the next couple of videos. See you then.